Okay, so today we're solving equations with variables on both sides. Really no different other than now we're not just moving constants, we're also moving variables around. And you are gonna learn something new in just a minute. So right now everybody's Chromebook should be completely shut down, not shut down, but you can close your lids and we're gonna get started. Now I will go a little bit faster today just because I wanna give you more time to practice. But if there is a point where you need me to stop, please let me know, okay? I also will not be going step by step through these because we did that in the last set of notes. One thing that I want everybody to remember is that in order to solve equations, you must isolate the variable. The key is to get that variable by itself. That is your key. Okay, so you're doing everything to get all the numbers that are near the variable away from it. And you're going to do that by doing the inverse operation. Another word for inverse is opposite. Okay. Now you're going to see something a little new on this first example. 5x plus 2 equals 2x plus 14. I do not have grouping symbols, so I'm not going to be distributing. If I look at my left, I don't have any like terms to combine. And if I look at the right, I don't have any like terms to combine. So what my focus now is I'm going to move all terms with variables to one side of the equation and all terms with constants to the other side. So that all my variables are on one side, all my constants are on the other. Now, it does not matter which side I move it to. So in this case, it doesn't matter if I move my 2x to the left or if I move my 5x to the right. However, when I look at my problems, I look at them and say, okay, how am I going to keep my coefficients positive? And that tells me which one I'm going to move. For example, if I move my 5x to the right, I will be subtracting 5x from both sides. That's going to give me a negative 3x. I don't want a negative 3x. I want a positive 3x. So then I will take my 2x and I will move it over to the left and subtract that, and it will give me a positive 3x. The next thing that I want you to understand is we are moving the full term of 2x, not just the number. So you're used to dividing by a coefficient. But with these problems, at the beginning, we're going to take the whole term of 2x and we're going to move it to the left. Now, is our 2x positive or negative? Positive. So I'm going to take the entire term and subtract 2x, the full thing, from both sides. Okay? And when I do that, I get rid of the 2x on this side. Okay? And now I have 5x minus 2x. We're combining those terms together. 5x minus 2x gives me a 3x. And then I write what I have left, plus 2 equals a positive 14 or just 14. Any questions about that first step? No. Did you take pre-algebra or 7th grade math last year? Then yes, it's a review.
Oh, I get it now.
Okay, so now after I have moved 2x over, I have all my variables on one side. Now I'm going to take my constants and move those all over on the other side, which means my 2 has to move over to where my 14 is. So since it's positive, I'm going to subtract 2 from both sides. This cancels out. 3x equals 12.
Dividing by 3.
And x equals 4.
Oh,
okay. Let me check something really quick. Okay. Any questions on that one? Jaden.
Okay, so would you never do like because you know have like 5x and 2x, so you always do with the subtraction will always stay positive?
No, you do not have to.
Okay.
That's just what I like to do. because I want to work with positive numbers.
I guess I got -4.
Okay, so let's say, I like this. Let's just do this. You guys don't have to do this one, but I'm going to show you what happens. Okay, so say instead he moved his 5x over. Is that what you did? So he subtracted 5x, subtracted 5x. So you get rid of this one and you're left with 2 equals -3x plus 14, right? Then what did you do?
And then -2 is 14.
Okay, now if you do that, though, you're leaving this side blank, empty, nothing's there, and we can't do that. So you would have had to move -14 over. So subtracting 14 from both sides, okay, you now end up with a -12 equals a -3x. This is still correct. You could do it this way. And then you just divide by a -3, divide by a -3. -12 divided by -3 is 4 equals x. Same answer. Okay. Right. All right. Now, moving on to example 2, we have decimals, and I want to get rid of those decimals. So what do I need to multiply the whole equation by to get rid of the decimals? And don't shout it out. Just think to yourself. Remember for our notes, we need to go the furthest place value. So what would that be, Sophia? 100. So I'm going to multiply this whole thing by 100, and all I'm doing is moving my decimal over twice in every single number. So go ahead and do that, and then rewrite your new equation. And then you can check it up here with me when you're done.
Mm-hmm.
Yes.
So big.
Okay, so you should have gotten 310x plus 920 equals 206 minus 115x. And now we're just going to solve like normal. So I want you all to do the next step. Okay. Okay. So the next step, you should add 115 to both sides, 115x. And you get 425x equals, oh, nope, not equals.
125x
Oh, I don't know what my thing is. Okay, so it's going to be
plus.
plus 920 equals 206. Then subtract 920. And 425x equals negative 714. I actually have done this so many times, but if you didn't know, you could just take 9, because they're different signs, you take 920 minus 206 and you get 714, and then because the 920 without the sign is the largest number,
Yeah,
it's negative, so it's negative. All right,
Miss Weatherman,
400, yes.
wouldn't we just make that into a fraction? A negative fraction? The 714 over 425?
Okay, so yeah, I was just going to address that
Okay.
because we started with decimal numbers. You want to have a decimal answer unless it's a whole number. So in this case, and I'm just going to tell you this, anytime you come up with a problem like this, you can use your calculator to solve it. I know that most of you know how to divide. That's not what I'm testing you on. I'm testing you on, can you get to this part right here? So I'm just going to use my calculator, and I'm going to take negative 714, negative 714 divided by 425, and I get negative 1.68.
But that's not what happened, right? That's what I did.
You can. I do not want you to waste your time doing all this division when you have so much work to do. If you end up with a big number like this, use your calculator to get your answer. You don't need it for anything else, though, that we've done so far. So that's how I want you to do those. Yes. Okay. Now we're going to move on to example 3. So these both have, or this one has grouping symbols. So I am going to distribute first. So I want you all to distribute. You're going to distribute your 2 first, and then distribute your 3. And you're going to rewrite your equation, and then you're going to check your answer when you're done. So just do that first step. When you're finished, I want you to look up and check to make sure your distributing was done correctly. Okay. Okay. Once you check it and you know you got it right, I want you to try to solve this one. It's very similar to example number 1. So follow those steps. Move all variables to one side, all constants to the other. Also, if you are finished and you're waiting, you can move ahead. You can keep doing the problems and then just wait until I get there. If you have any questions, you can also start on your homework as soon as you finish your notes. Yes?
Whenever there's a negative in front of a 9, and you're gonna, there's no like, there's something in front of it, the negative becomes a positive, or positive 9, yeah, on both sides.
Are you talking about example 5?
Yeah.
Well, your 9m is positive, your 4 is negative.
Well, on the finish side, you have to do a combine that term for the other side,
Mm-hmm.
and do 9m.
Yeah.
Negative 9m. So you do plus 9m for each side, because it's negative.
Okay, we're gonna get there. So stop. If you don't know what to do next, just stop and then wait until I get there. Yes, Stone.
You also do the homework or just?
Finish your notes first. Yeah, Ethan. Yeah. Okay. I am going to go ahead and start solving this. I want you to try this on your own though, okay? So everybody should be working on this on your own.
I don't know when I do it.
Okay.
Miss Weatherman,
Yes.
um,
Oh, wait, hold on.
what if you canceled like -2 before like doing the 10x and 3x?
That's fine. You can move your 2 over first.
So you could do either one?
Yes, you could do either one.
Okay.
Yes, so Jaden,
Mrs. Weather.
hold on, Mo. Jaden had a really good question. Do you have to do your variables first? No. I start with my variables because those are the ones I want to keep positive. But if you were to, on this one, if you were to add 2 to both sides first, that would not be wrong. You can do that first. Hold on, Momo. Stone, do you have a question? Oh, wait, hold on. Wait until I get there. Momo.
Yes. So
You're muted.
on number okay, sorry. On number 4.
I'm not there yet.
Okay.
Okay, wait until I get there. Okay, I want everybody to try example 4. Wait, no, we're gonna do 4 together. I'm sorry. So on the left side, there's nothing to combine. So I'm going to just go ahead and write 10x plus 12.
Equals.
And then on the right side, I can distribute. So distribute my 2 and my 6. And I end up with
10x plus 12.
10x plus 12. What do you notice about this equation? Stone? They're the exact same on both sides. Okay? So what we call this, and I'm going to show you why we call it this, we call this the identity property because they can identify with each other because they're both the same, right? Your answer though is infinite number of solutions. And we abbreviate this to infinite number like that. Now, I am going to explain to you, show you why this is the case.
Yeah. I'll probably one.
Mm-mm. Okay, I'm going to show you right here. Okay, I'm going to rewrite this 10x. Okay, so your goal in solving equations is to figure out what x is. So that when you plug x back into the equation, you remember how we checked equations, we checked them to make sure they're true, is to make sure that the left side matches the right side. So for example, if I had 2x plus 5 equals 11, okay, just to show you this example, and I solve this equation,
Bless you.
and I get
3. Bless you.
x equals 3, right?
Yes.
And then I said, you can go back and you can check to make sure that it's right. So what I could do is I can take my 2x plus 5 equals 11, and I could plug the 3 right here into the x to see if the left side matches the right side. And if it does, then that is a solution to the equation. It makes the equation true. So I could take 2 times 3 plus 5 equals 11. And then I start solving. 2 times 3 is 6. And 6 plus 5 is 11. It checks out. It checks out. So what that is saying to me is that 3 is a solution to this equation, because when I plug it back in, it makes the left side equal the right side, which means it makes the equation true. If I were to plug 1 into this equation, it would come out false, because my left side would not equal my right side. Does that make sense? Okay, so now let's go back to this problem. If I were to plug in 3 into this equation, what do you think will happen?
It'll be off.
Do you think the left side will equal the right side? Let's try it. If I take 10 times 3 plus 12, and then 10 times 3 plus 12, I have 30 plus 12. 30 plus 12. 30 plus 12 is 42.
You forgot about the x.
No, I plugged 3 into the x. It's true. So 3 is the solution to that equation. What if I chose, I don't know, -5?
Could be.
10 times -5 plus 12 equals 10 times -5 plus 12. I have a -50 plus 12 on both sides.
-38. -38 equals -38.
Yes. And that is why it's identity. That's why it's infinite. What this is telling me is that it doesn't matter which number I put into this equation, it will always be a solution. It will always make the equation true. That is why we call it identity, or infinite number of solutions. Jaden.
Can you just put an A notes? I-N-O-S.
If that's what you want to write, yes, I'll know what that is. Okay. Yes.
Do you have to put like a number in, like, do we have to
Prove it.
do it?
Once you get to this point, then you can write infinite number of solutions. Now, let me show you what happens though if you try to solve this, because some of you aren't going to catch that it's an identity, and you're going to continue to solve, which is perfectly fine. So 10x plus 12. So say you start solving and you subtract 10x and you subtract 10x and you get 0x plus 12 equals 12, because you canceled it out.
Amen.
And then you subtract 12 and you subtract 12.
This equals 0.
you get 0x equals 0. When you get to this point where 0x equals 0, know that it is an identity. When we get to number 5, it's going to be similar, but there's one difference that will where it will not be an identity. But once you get to this point, or you notice, oh, it's going to be 0 on both sides, just know that it's an identity. Okay. All right. Now we're going to do something. We're going to go to number 5, which is a little bit,
Miss Weatherman.
actually, yeah, it is going to be a little bit different. Yes.
No.
So then what would we put as the answer for?
Here, infinite number of solutions.
Okay.
Now let's go to example 5. We have 9m minus 4 on the left. We can't combine it with any terms. So we look at the right. We can combine terms. We have a negative 3m
Plus a 12.
plus a 12m. So let's go ahead and combine those. We have 9m minus 4 on the left and 9m plus 5 on the right. Okay, is that an identity? No, because we have a negative 4 on this side and a positive 5 on this side. So we're not at an identity yet. So what I'm going to do is I'm going to subtract my 9m from here and move it over to the left.
No. Toby.
And I have 0m minus 4 equals 5. Now I'm going to add 4 to both sides. You could stop here, by the way, and I'll show you at the end why you can stop there. But I want you to keep writing your answer. 0m equals 9. What do I do now? Divide by 0.
Okay.
And what does m equal?
0.
Okay, if you have a calculator out, okay, let me show you something. I'm going to take my 9. I'm going to divide it by 0. What did I get?
Error.
Error. Okay, that means that there is no solution.
Uh-huh.
Let's go back to when Mr. Mack taught you about slopes. What was a vertical slope called?
Up and in.
It was a bad word in math.
It was like a,
Undefined.
Undefined.
Momo.
Okay, that's what this is.
That was me,
Oh, who? Jaden?
Andy.
Oh, Andy. Okay,
Oh.
sorry, Andy. I don't have your pictures up quick, so I couldn't see who was talking. But
Sorry,
it's
Andy.
undefined. Okay, it is an arrow. If you see that sign over there on the wall, it's all fun and games until someone divides by 0 because you can't do it. It's impossible.
No, it's 0.
So whenever you have a number being divided by 0, there is no solution.
It's all funny memes.
Okay.
Somebody divided.
Now, what if and if you want to write this at the top of your paper, you can. A number divided by 0 is no solution. What about 0 divided by a number? It equals 0. And even if you were to plug that into your calculator, you'll see 0 divided by 9 is going to give you 0.
and divided by 0 is 0.
Anything divided, no, 0 divided by anything is 0. If 0 is your numerator, it's 0. If 0 is your denominator, you have a big fat problem because you can't do it. There's no solution. Okay? Okay, so let's look at example 6. We have 2a plus 3 on the left. We can't combine anything.
But you can.
Okay, and then on the right, we have the distributive property. Now I'm going to distribute 1/2 to 6. 1/2 times 6. There's 2 ways you can look at it.
3.
You could say, okay, what is half of 6?
3.
Or what is 6 divided by 2?
3.
3. Now what you're actually doing is you're taking 1/2 and you're distributing it to the 6 or multiplying it, and you get 6 over 2, which is 3. So this is what the math you're actually doing. But if you can do this part in your head, I would do that. So then what is 1/2 plus 4a?
2.
2a. Okay, So what do you see at this one?
Minus 8.
Infinite number of solutions. It's identity. Even though your 2a plus 3 is reversed on this side, I could move my 2a over here and get 2a plus 3 equals 2a plus 3. It is the same. So this would be infinite
Identity.
number of solutions. And that's your answer for this one.
That's your
Okay.
answer. So
All right.
Wait. So Miss Weatherman, if we see that on, like, for example 6, if we see that on our homework, like we see example 4 or example 6 on one of our homework problems, can we just put down an infinite number of solutions?
You have to show me why it's an infinite number of solutions. You have to actually write this out.
Miss
So-
Weatherman.
You have
What
to
can I
write
do?
this step out. Yes?
I got a quick question. Number
So we're going to do one word problem and then I'm going to have you practice. Okay? So it takes a graphic designer 1.5 hours to make one page of a website. Okay? An hour and a half for one page. Now this designer wants to buy some software that will shorten the time. And so it says, using new software, the designer could complete a page in 1.25 hours, but it's going to take him 8 hours to learn it. So he's trying to weigh the cost. Do I want to buy the new software? Will it eventually save me time? Or do I want to stick with the old software? Okay. How many web pages would the designer have to make in order to save time? Okay. So the first thing we're going to do is we're going to look at the old software. Old software. What is our expression for the old software?
1.5.
Anybody else? For the old software? Okay, it is 1.5. We have to attach a variable and we're going to H for hours or P for pages. Let's see, how many web pages? So we're going to do P for pages. 1.5 P. 1.5 hours per page is basically what that is. Now with the new software, what would the, each page is 1.25, but it takes 8 hours to learn. So how would we write that expression?
1.25 P plus 8 hours or 8 H.
8. Mhm. Okay, so now we're trying to figure out which one is best, but we need to come up with an equation. Okay, so does anybody know how we're going to do this? Christian?
Yeah.
Oh, hold on, let's see if Christian knows.
So would you have to put up all in the equation and stuff and then try to figure, oh God, I don't know.
He doesn't. Okay, Mo, what do you think?
I think we would have to do 1.5 P. Actually, wait, no. 2.5 P plus 8 hours equals. Okay, this is kind of hard. Wait.
Jaden.
I put 1.5 P equals 1.25 P plus 8.
Yes.
Yay!
So this is how we're going to figure it out. We're going to set them equal to each other to see how many pages they can make in the same amount of time. And then we increase it by 1 because after that, then with the new software, they'll be saving time. So I'll explain that again. You're going to take 1.5 pages, set equal to 1.25 page or 1.25 hours per page plus the 8 hours of learning. And we're going to solve and see how many pages can they make in the same amount of time, because that equal sign means you're wanting to find the same amount. Okay? Or the same number of pages. So let's figure that out first. Now,
Just learn the software and just get the people.
I'm going to multiply everything by 100 to eliminate my decimals. we have 150p equals. And don't forget to multiply 100 times the 8. Okay,
Mr. Weatherman, I got a question.
sure.
So if you're gonna do this and we're doing ×1 for each thing, wouldn't we just start the 125p plus 800 hours? Because you have to learn that.
Well, you can't combine those because 800 doesn't have a variable. It's not changing. And maybe I'm misunderstanding your question.
So like if you said that if we're doing it, then we just say, so you make 1 page per 150 hours or 1.5, but without the decimal. So it would take you 800 hours plus 125 hours to equal 1 page, right?
Right.
Okay.
So then we divide by 25. Anyone know what 800 divided by 25 is off the top of your head? 32. So once you get to this point, this is telling us that with the old system, when they make 32 pages, the new system has also made 32 pages. So it would be 33, because what's going to happen is when they make their 33rd page, it's going to take the old system 1.5 hours, but it's going to take the new system 1.25. So they've saved 15 minutes. And then the 34th page, they saved half an hour. The 35th page, 45 minutes, and the 36th page, an hour. So every 4 pages now, they're saving an hour of time with the new system.
Wow.
So the answer would be 33 pages.
I'm confused.
Was that?
Like, I don't understand.
Okay.